Hello viewers, I'm Kausalya. Today we are going to solve problem number 3 and 4 in RL series circuit. So here the problem is a voltage V is given by 238 sin 314T is applied to a coil having resistance of 50 ohms and inductance of 0.159 Henry. Find the expression for the current I and calculate the real power. So first we are writing the given parameters. So expression for voltage, value of resistance and value of inductance. Right. So here we are asked to calculate the current and the real power. So the first thing is, you see, since this is an RL circuit, right? So what will be the expressions for voltage and current? You see, voltage is given by V equal to Vm sin omega t and I is given by Im into sin omega t minus pi, right? So here we are provided with a general expression for voltage, right? So you can just compare. So V is given by this expression. So we are comparing it with the standard expression. So what is the value of Vm? It is 238 volt. And when you compare in the place of omega, we are having 314, right? So the next thing is the inductive reactance is given by, it is denoted by XL, and XL is nothing but L into omega, right? We know the value of L, we know the value of omega. So just substitute and calculate the answer. It is 50 ohms, right? And the next thing is we need to find the expression for I. So for that, you see, the value of I is given by Im is equal to Vm by Z. What is the value of Z here? In an RL circuit, Z is given by square root of R square plus XL square. So we know the value of R. It is given in the problem. We had calculated XL. So just substitute it and the value of impedance is 70.7 ohms. Right. And the next thing is we are going to calculate Im. Im is given by Vm by Z. And Vm, you see, by comparing these two expressions, we had calculated Vm. Right. And so just substitute the values. So Vm is 238 and the value of Z is 70.7. So that gives the answer as 3.37 amps here. Right. You see, for writing expression for I, what are all the parameters you need? We need to calculate Im and we need to calculate pi. Because omega we had already calculated from this voltage expression. So how to calculate the value of pi? You see, it is given by this formula. Tan pi is equal to XL by R. Right. So here pi is nothing but tan inverse of XL by R. We know the value of XL, we know the value of R. So just substitute here. So that gives tan inverse of 1. So tan inverse of 1 is possible when the angle is pi by 4 or 45 degrees. Since it is an inductive circuit, here the angle is mentioned as lagging. So while writing the expression, you see I is equal to Im into sine of omega t minus pi. So just substitute the value of Im, omega and pi here, right? And the next thing is we are asked to calculate the real power. So real power is given by this formula Vi cos pi, that is Vrms into Irms into cos pi. So here we just know the value of Vm and Im, right? So how to calculate Vrms? You have to divide those values by root 2. So Vrms is nothing but Vm by root 2. Similarly, Irms is nothing but Im by root 2. So just substitute the values and calculate, and here we are ending up with the answer as 284 watts. Right. Now we are proceeding with our problem number 4. You see, here two impedances are connected in series across a 200 volt supply. Calculate the current, power factor and power. Right. So here we are having the impedances, right? The value of Z1 and Z2 are given. So you just write them, right? And the voltage is 200 volt. So, and you see they are connected in series, right? So I had drawn a diagram like this, right? So how to calculate the total impedance? Just you have to simply add. So when you add here, you see we are getting the answer as 15 plus 0j or 15 with an angle of 0 degrees, right? Therefore, the total impedance is nothing but 15 ohms and the angle is 0 degrees, right? So here the next thing is we are going to calculate the current. So current is given by V by Z here. So just substitute the values. You know the value of V, that is 200 volt. Okay, therefore the angle is 0 degrees and here impedance is calculated as 15 with an angle 0. So the final answer of current is 13.33. Again the angle is 0 degrees. And the next thing is calculating the power factor. It is given by cos pi. Since the pi is 0, the power factor value is 1. And the next thing is to find power. Power is given by again Vi cos pi. So here in this case, V is directly given and we had calculated I and cos pi. So just substitute it here. And the final answer is calculated as 2,666 watts, right? Because here directly the source voltage is given, right? So whenever the source voltage is given, it is nothing but our RMS value, right? It is not the maximum value. Keep that thing in your mind. And again we will proceed with this fifth problem. So here a coil when connected to a 200 volt 50 hertz supply takes a current of 10 amps and dissipates 1200 watts. Find the resistance and inductance of the coil. So here whenever we are considering the term coil, a coil will always have both resistance and inductance, right? So here the supply voltage is 200 volt 50 hertz and it takes a current of 10 amps, right? And the power dissipated is 1200 watts. So what are all the data which are given? We are provided with current and the power. So power is given by the formula I square into R, right? We know the value of power, we know the value of current, therefore we can easily calculate the R value. So just substitute it over here and finally the value of R is given as 12 ohms, right? And the next thing is we need to calculate the value of L, right? So to find the value of L, you see we are calculating the impedance. So impedance is given by V by I. We know V, we know I. So therefore the impedance value is 20 ohms here. So impedance is given by this formula square root of R square plus XL square, right? We need to calculate L. Therefore, we are rearranging this expression. So, XL square is nothing but Z square minus R square. We know Z, we know R. So, just substitute and calculate the value of XL. It is calculated as 16 ohms. But we need L. Therefore, XL is nothing but 2 pi FL. So, just L is nothing but 16 divided by 2 pi F. So, here, what is the value of F? It is 50. Right, so just substitute the values and here the answer is 0.0509 Henry, or you can write it as 50.93 millihenry, right? So here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.